Hello everyone. I am Areen Singhade and currently I'm pursuing my BTech in IT from SG Cities Indore. Today we will be learning about foreign key constraints and what actually are foreign keys, why are they even used in relational database systems, and also how to ensure referential integrity in relational databases, and why is it important, and why this foreign key exists as a concept as a whole. So we will be learning about all this. So I have prepared a set of slides. So we will be going through each and every slide, and I will try my best to explain what goes on in foreign keys. So what is actually a foreign key? A foreign key is nothing but a column or a group of columns in one table that refers to the primary key in another table. So it is basically, when we say relational database, right? It is basically the concept of primary key and the foreign key, which makes it relational, because the the power of foreign key is such that you can connect two tables and you can have one table referencing to another table, which is quite powerful because then you can have many sorts of functionalities which are just not available in NoSQL databases, and you also need them to normalize data to make query more efficient, to make storage more efficient, and then the ultimate organizational goal is to optimize costs, and therefore foreign keys are very very important in that aspect. So as it is written here, it's used to establish and enforce a link between the data in two tables. So this is what a foreign key is. Foreign key is nothing but a column in a table which references the primary key of another table. And then you can use both of these columns, the primary key of, let's say, table A and the foreign key of, let's say, table B, and then you can have many relational queries that you can run parallelly on that. So why use foreign keys? Like as I said, it enforces referential integrity. Okay, so because it's very common sense that if table A contains let's say 15 primary keys, then table B, which contains the foreign key of table A, which references to table A, it cannot contain more than 15 foreign keys, because as primary keys are unique, foreign keys should also be unique, correct, because it references to them. So enforces referential integrity. It also avoids orphan records. Orphan records are basically those records which uh, like I have an example coming up in the slide which explains what orphan records are, but it is nothing but like if like let's say table A has a primary key and table B has a foreign key, that's valid. But if table B has a foreign key but it does not reference to any primary key in the table A, that's an orphan record, and this should not be there in data because it really affects the integrity of the data as well. It ensures data consistency, again, the same point, and establishes logical relationships. So this is the most important of all points, because if you cannot establish logical relationships between two tables, you will not be able to write business logic. And if you are not able to write business logic on the data layer that you're working on, it gets very, very complicated. And then basically it's a data lake or data warehouse. It is not a managed database system, because the very definition of a database management system is it can be queried over very very efficiently, very fast, to get the results and to get the business outputs that we want. So for example, this is an example of an orphan record that, let's say, notebook A contains a list of students. So just imagine that there are 30 students in a class, and all of them have primary key from 1 to 30. And notebook B contains fee payment details, and let's say only 25 students out of 30 students have paid the fees of their classes at this point of time. So what will happen is, if the student ID in notebook B doesn't exist in notebook A, then it's basically invalid because this is what a foreign key protects against. So what cannot happen is no student which pays fees. Uh, so so you have to be a student to pay a fee, correct? So that is what this logical relationship is telling us. That a teacher cannot pay the fees. Okay, the student has to pay the fees itself. And this is what this slide is telling us. So if you don't exist in table A as a student, you cannot pay fees and you cannot have an entry in table B. But if you have an entry in table B and you're not a student, it will flag us that this is a referential integrity problem and you should avoid this. So this is what foreign keys are supposed to do. Also, this is a normal syntax that how you create a foreign key. So you basically create a table called orders, and for example, let's say every order ID is int and it's the primary key there, and the customer ID is also an int, and then the foreign key is basically customer ID references customer ID. So what this query is telling us is that foreign key customer ID references customers. So for example, we have created orders as a table here. A customer is a table that is already existing in the database. So it references the customer ID column of the customers table with this table. So this is what this query is telling us. So it's pretty simple to implement, but it's very, very powerful at the same time. So we can have types of relationships. For example, one to one. So one primary key in one table can reference to one foreign key in one table can reference to one unique primary key in another table. We can have one to many. So most common with foreign keys, this is and there is also many to many, which is handled using junction tables. Junction tables is out of the scope of this PPT, but they are also quite oftenly used in practice in industry. With foreign keys come cascading actions, because if you think about it, if I am deleting a record, um, and it contains the primary key, and in some table in some another table a foreign key references this primary key, then when I delete the record which contains the primary key, the data of the foreign key should also be deleted, correct? Because that is the whole agenda of using foreign keys, and that is to maintain the referential integrity of the whole system. So if I am deleting a record excuse me, so if I'm deleting a record which contains the primary key, then whatever foreign keys are referencing to that primary key, they should also be deleted at the same time. And then we come to the crux of this PPT, errors and constraints. So you cannot insert a record in child table if parent does not exist, because you cannot reference to something which does not exist, right? So you cannot point to a void place. A primary key should exist so that foreign key can reference and point to that primary key. And also you cannot delete from parent if referenced in child. So unless cascade is used, you cannot delete a parent if if a child references the parent. So that is not possible. If you use cascade, then the literal meaning of cascade is they will delete from bottom to top. So for example, when you use cascade, right? If it is deleting one primary key, it will delete all the foreign keys that references to their primary keys. If the cascade command, if the cascade keyword is not used in your program, then this will not happen. This will simply not happen, and it will not allow you to delete any records. So yes. Best practices are always use index foreign keys for performance. So you have so what are indices? Indices in a database basically helps you to optimize query time and the time on the disk. So once you have these indices of foreign keys, it basically helps you to search for them faster. Use not null only if required, because foreign keys can be null, but primary keys cannot be. So only if required use not null, but yeah. Carefully choose between cascade and restrict, and use constraints during table creation. So this is very important if you want to maintain that integrity throughout your database. So in summary, foreign keys maintain data consistency and integrity. As I've explained, help define relationships between tables because they can reference to some table which has a primary key, and it is key in building scalable and normalized databases. So for any database you have to normalize them, and for normalizing them you have to reference from one table to another table because that is what normalization actually means, and this is achieved through primary key and foreign key, the combination of both of these. And to build a scalable database, you just cannot store everything in one table. You have to have many tables referencing and pointing to each other, which are related and correlated between them, which have relationships between them. So therefore, the whole concept of RDBMS exists because primary key and foreign key exist. So this is very, very important, and this is one of the most important things in databases. So this is the crux that makes database management systems relational database management systems. So yes. So thank you so much for listening to me. I hope whatever value I could add, I added. So thank you so much. Thank you.